So, doctors, now let's start our lecture. First of all, I announce that we will start the very important new topic, doctrine about tissues. We will study this material several lessons, and almost all future lessons in this semester will be about the tissues. Now you see that tissue, you have to know the definition about tissue. What is a tissue? Tissue, it is complex assemblage of cells and cell products that have a common construction, origin, and structure and function. What main components may be in the tissue? Most of the students think that only cells. No, not only cells. Cells, it is the main element of the tissue. But additionally, our tissues consist of cell products like extracellular matrix. It is non-living macromolecules who are produced by cells of this concrete tissue and fill the spaces, extracellular spaces between the cells. Some tissues has a lot of extracellular matrix, like connective tissue, when the volume of the connective tissue prevalent to the volume of the cells in many times. On the other pole is epithelial tissue, which is very poor in extracellular matrix, and only the basal lamina, it is the extracellular matrix for this type of tissue. Besides this, tissues can have the so-called postcellular structures. These postcellular structures are derivatives of the cells and maybe of different types. For example, symplasters. Symplasters present in placenta, also in our, it is our striated skeletal muscles. On this picture, you can see the striated skeletal muscles. You can see that it is fibers which appear of the fusion of many cells, myotubes, during the prenatal development of the man. And these symplasters express the huge mass of cytoplasm and plenty of nuclei as a result of fusion of many mononucleated myotubes. The second type, it is syncytium. Syncytium, you can see this word, syncytium, appear as a formation of many cells who has contact with one another. Cells divide methodically, but don't fully separate from one another. And the good example of the syncytium, it is mesenchyme. You have studied it in the embryology, lesson of the human embryology. Also, epithelial cells of the stroma of the thymus gland and pulp of the enamel organ. Then, now you see the mesenchyme. You can see that cells has processes. You can see processes, and cells contact with one another by these processes. Earlier, we thought that cells has no any boundaries between one another. But recent researchers show us under the electron microscope that here is tight junction. Between the processes of the neighbor cells forms the tight junctions, and each cell separates from one another by the cytosol. But together appear the huge mass of cells and it is syncytium. Also, maybe post-cellular structures like cells who lost its nucleus or most of organelles during the differentiation. And the good examples of such post-cellular structures are erythrocytes, platelets, which I already tell today, and, for example, horny cells on the upper layer of the stratified squamous keratinized epithelium. These post-cellular structures are highly specialized to perform special function. For example, erythrocytes has no nucleus, no organelles, but has hemoglobin. It is special protein for which can bind oxygen and carbon dioxide, and it is the main function of these cells, these post-cellular structures. But the lifespan of such post-cellular structures is limited. They can't divide mitotically, they perform their function and then dies. For example, erythrocytes lies over 120 days and then destructed in the red pulp of the spleen. If we will talk about the tissues, you have to know the systemic principles of the organization of the tissue. Each cell has its own function, and we have studied cytology yet, previous lessons, and now you know that cells can be organized into tissues, and together cells can perform more functions than each one cell. That's why appear the principles of the organization of tissues. Tissues usually, I repeat once more, consist of cells and cell derivatives, extracellular matrix, and post-cellular structures. And our tissues forms organs. Usually our organs, it is combination of all 4 types of tissues which have the human body. Between histic and organic level is level of morphofunctional unit. Later, when we will study and discuss the microscopic anatomy or special histology, we will talk about the morphofunctional units in each organ. It is the smallest replicating part of an organ fulfilling its function. Now, for example, it is nephron in kidney, follicle or in the thyroid gland, or hepatic lobule in the liver. That's why the middle between the tissues and organs, it is morphofunctional unit. In the 20th century, some scientists created the laws of the tissues. First of all, it is theory of divergent development of the tissues in phylogenesis and ontogenesis. This theory says that our tissues divides in divergent directions, branches. For example, first of all appear 3 germ layers, ectoderm, mesoderm, and endoderm. Then, during the fetus development and during the postnatal life, from ectoderm appear several types of epitheliums of different organs. For example, from ectoderm appears stratified squamous keratinized epithelium, which covers our skin or cornea of the eyes. Also appear the stratified squamous non-keratinized epithelium, which covers our oral cavity, esophagus, and the distal third of the rectum. From endoderm also can appear several types of epitheliums. For example, simple columnar, simple cuboidal epithelium, in which are present in different organs. That's why theory of divergent development of the tissues in phylogenesis and ontogenesis says that from previous germ layers, first was germ layers and then appear different types of epitheliums. Human beings at the top of evolution, that's why we have many types of epithelium. You have this week, you study and discuss epithelium and know the morphological and histogenetic classification of the epitheliums, for example. That's why this theory uncovers the basic directions of evolution of tissues. This theory was created by the Russian scientist Chlopin. Here his name, Chlopin. Next law of tissue, theory of parallel development of tissues. Theory of the parallel development of tissues. What does it mean, parallel? It means that the tissues present in all living beings on our earth. Tissues has plants, tissues has animals, and tissues has man. But, for example, again, epithelium tissue. Epithelium tissue present everywhere and has the same principle of organization. Absence of extracellular matrix, presence of the basal lamina, and so on. Same for connective tissue, same for the muscle tissue, and same for the nerve tissue. That's why, let's summarize that this theory emphasizes adaptable properties of tissues and uncovers the reasons of their evolution. Today, the most modern theory of the tissues, laws of the tissues, it is universal theory of divergent development of tissues and parallelism in their development. It was created by Brown and Mikhailov, according to which similar structures in various branches of phylogenetic tree arose parallel during the divergent development. Development of tissue we open by the word of histogenesis. It is new maybe word for you. Histogenesis. It is development of tissues. Histogenesis may be prenatal and postnatal. But in the base for histogenesis, each tissue type has its own histogenesis, and it based on the process of determination and differentiation of their cells. Determination of tissues, it is about the genome of the cells. You remember embryology and know that first cells which appear as a result of cleavage, blastomeres, has totipotentia. It means that all their genes are opened and can work. But step by step, from these primary cells appear cells of ectoderm, endoderm, mesoderm. Then this ectoderm, mesoderm, ectoderm give rise to mesenchyme, to different types of epithelium, to types of connective tissue. У меня лекция, извините, попозже будет. Determination means the arrest or programming of the direction of the development of the cell. It means that some genes are arrested, and in concrete cells, for example, a cell of the skin or cell of the smooth muscle cells, only some part of genome is active, and we call it as euchromatin. But other regions are arrested. DNA is highly coiled, and we call it as heterochromatin. This heterochromatin appear as result of determination of the cells and the tissues. Determination provides the differentiation. It is process during which cells of the given tissue implement potentials anchoring by a determination. That's why during determination, some genes are arrested, but other works. And according to this euchromatin, cells start to produce proteins, and these proteins provide the special function of these cells. That's why differentiation, it means that cell gets special proteins, get special organelles to perform the concrete function. For example, secretory cell of the salivary glands produce saliva. It is their function and result of differentiation, which was and the base for this differentiation, it is determination of this genome. Next new word for you, I think it is differon. Differon. Differon, it is plurality of all cells amounting the given line of a differentiation. Now it is population of cells of concrete tissue on the different steps of differentiation. From at least differentiated, they get name, international name, stem cell, up to the most mature differentiated cells. By simple words, the stem cells, it is young cells who can quickly divide methodically, who can potentiate to differentiate in different types of cells in special conditions. And then step by step differentiates will be determination of their genome. They will differentiate, perform its function, for example, like cell of the liver or cell of the muscle tissue, and then cell become old. These mature differentiated cells can become old. After some period of time, it becomes old and then dies. So that's why differon, it is population of concrete cell where cells are on the different steps of differentiation, from stem cell up to the mature cell. Now let's talk about the basic types of tissues. Our body, or in the all living beings of the earth, we distinguish four basic types of tissues. Epithelial tissue, here epithelial tissue, then connective tissue, muscle tissue, and nerve tissue. Epithelium tissue usually covers the body cavity, the body cavities, skin, and forms glands, the secretory components of all our glands, endocrine and exocrine. Connective tissue underline or support the other three basic types: epithelium, muscle tissue, and maybe nerve tissue, but not very widespread in nerve tissue. muscle tissue collect the cells or symplastas, cell derivative, who are able for contraction, which provide our ability for movement. And nerve tissue, it is special combination of special cells and supporting cells which can receive, transmit, and integrate information from outside and inside, and also control the activity of our body. Usually nerve tissue forms our central and peripheral nerve system. All these types of tissues and their subtypes we will study during the practical classes. Some of them I'll tell you during the lecture. And today our topic will be about the blood. Blood, it is our internal environment and the subtype of the connective tissue. Blood has all characteristics of the connective tissue. It has the extracellular matrix, which is fluid in this subtype of connective tissue. The fluid component of the blood has name plasma, and cells and postcellular structures. Together we call them as formed elements of the blood. Then, if blood it is fluid, we can't make the original histologic section. And blood examination can be performed on special constant microslides, which has the name of the smear. Smear is done when we can be done if we take the microslide glass, put the drop of the blood on this glass from the finger, for example, and then take the second microslide glass, put it on the drop of the blood, and slide this blood on the first microslide glass. Appear the very thin layer of blood. Then we dry it and stain. The current method for the staining of the blood smear, it is staining by Romanovsky and Gimse. Staining by Romanovsky and Gimse. This method was created in the 19th century, and today it is standard staining for blood smear, for the blood examination, general blood examination, in all countries in the world. Not only in Europe, but also in Asia, in India, in Latin and Northern America, Australia and Africa, everywhere. Here in this staining, instead of hematoxylin, we use methylene blue. And the second dye is eosin. In this case, methylene blue stains acidic cellular components in blue, like hematoxylin. Now, eosin as usually stains alkaline component pink. And all morphology of the blood elements we describe after this staining. If we will use another dyes, will be another picture. And in some clinic situation, laboratories, a doctor who has specialization in the field of hematology, can use another dyes if we want to see something special. But general blood examination is, in all cases, can be done only after staining by Romanovsky-Giemse. Now you can see the functions of the blood. Now I will tell about this very quickly because I'm sure that you know. First of all, protective function, special cells, leukocytes, also platelets helps and participate in the protective function, in the immune response. Also respiratory function, transmission of oxygen, carbon dioxide, trophic function, transmission of nutrients, excretory functions, that tissue fluid which wash the cells and take the toxic byproducts of the cell metabolism, return back to the fluid component of the blood, and then blood pass by the kidney and appear the urine. Urine appear in the liver cells, but so urea, not urine, but urea. Urea, it is detoxicated component of the protein toxic metabolism. That's why blood concentrates the urea, some other products, and then it filtrates in the kidney. Then humoral function, that blood carry hormones, and homeostatic function. Fluid component of the blood, it is buffer solution, which helps in the maintenance of the constants of the internal environment of our organism. Tissue fluid, it is usually physiological solution. It is not simple water, and blood equalize the pH of our internal environment. Plasma and of the blood, you will study in details components of this blood, of this plasma. You will study next year in the Department of Biochemistry. My task to explain you the normal morphology of the formed elements of the blood. Only our department explains the students the normal characteristics of the peripheral blood of the healthy person. So our formed elements of the blood constitute three types. First, it is erythrocytes or red blood cells. Then leukocytes or white blood cells. Leukocytes are really cells. And platelets or thrombocytes. Erythrocytes and platelets are postcellular structures. All students and all doctors know hemogram. And you, like the future doctor, have to know hemogram. What is it, hemogram? It is a count of each formed elements of the blood in cells in 1 liter. The first line in hemogram occupy the erythrocytes, also called red blood cells. Their account depends from the sex. Female has less than male. Female 3 to 7 to 4.9, 3.7 to 4.9 times 10 power 12. Here it is power 12 cells in 1 liter. Male 4.5 to 5.5 times 10 power 12 cells in 1 liter. I told you that it is postcellular structure who are specialized for the transport of the oxygen from the lungs to the tissues and carbon dioxide from the cells of the tissues back to the lungs. In the cytoplasm of these cells, absent nucleus, absent all organelles, and only hemoglobin, this word, hemoglobin, occupy all the volume of the cytoplasm of erythrocytes. The normal diameter of erythrocytes 7 to 8 micrometers. Shape biconcave in human. It means that may be depressions in the central region of the erythrocyte. In this region previously locates the nucleus. Now you can see the scanning electron microgram of erythrocytes, and you can see the depression in the center. From the other side, also depression. So after staining by Romanovsky-Gimze, erythrocytes get the homogeneous oxyphilic color. It means homogenic red color. But in the center where is depression, present so-called central polar, the light region. The second line in hemogram is occupied by the reticulocytes. Reticulocytes are young erythrocytes who has some organelles, reductive organelles in the cytoplasm. That's why reticulocytes get the blue granules in the cytoplasm. And the cytoplasm get the slightly blue color. The account of reticulocytes in healthy person up to the 10% of total account of erythrocytes. These cells have to be in the red bone marrow, but up to 10% can go to the peripheral blood and be in the peripheral blood. You see the steps of its transformation. After several days, they pass these 4 stages and will look like these mature erythrocytes. If more than 10%, it is anemia, and doctors have to understand what happened with this person. It is not normal situation. Maybe inner bleeding, maybe other situation. The lifespan of erythrocytes is limited, and they live over the 120 days. When they come to this age, they change its shape and become spheric. These depressions in the center disappear and cells become spheric. Very interesting that some mammals, almost all mammals, have no nucleus in erythrocytes, but some mammals can have. For example, camels and llama. Usually these 2 animals, only 2 mammals, has this, maybe some lower llamas. I'm not a very well qualified biologist, but higher mammals, only camel and llama has nuclei in the erythrocytes. If you ever saw the blood examination, no, I'm sure that most of you passed the general blood examination. You can get the list of this examination. And here is hemogram, usually, leukocytic formula, and some words are printed. First of all, it is word anisocytosis. Anisocytosis, this word. What does it mean? It is about the size of erythrocytes, variations of the size. I told you that normocytes has diameter 7 to 8 micrometers, and it constitutes over 75% of our peripheral blood, of course, of the healthy person. But 25% is occupied by macrocytes and microcytes. 25 is divided into two. That's why 12.5% to macrocytes and 12.5% to microcytes. Macrocytes are larger than 9 micrometers in diameter. Microcytes is smaller than 6 microns or micrometers. Both, so it is normal. If you will see that laboratory underline the word anisocytosis in your blood examination list or your patient list, you have to understand that these correlations change. And you have to send this patient to the detailed blood examination. Both situation is not very well. If increase the number of macrocytes, it is pernicious anemia, vitamin B12 deficiency anemia. Many centuries it was the mortal situation. We can't live with large erythrocytes. They can't perform its function. And people died. Today we know that this person need the injections of the vitamin B12. Next semester you will understand why. Only injections. And person will be healthy. Of course, you have to care this person every year and again repeat these vitamin B12 injections. Microcytic anemia also is not good situation. About reticulocytes, I told you, no more than 10%. Some words about hemoglobin. Now you hear the international abbreviation of hemoglobin, HB. It is international abbreviation of hemoglobin. Hemoglobin, it is special protein. We call it as red pigment, which gives the red color to erythrocytes and totally to the color of our blood. This protein has 4 globular proteins which bind to one another, and each globular protein has Hem group. It is iron, ferrum. In the Department of Biochemistry, we'll study in details. Hemoglobin can bind oxygen in lungs and appear oxyhemoglobin. These erythrocytes with oxyhemoglobin has bright red color, and bleeding, and if it hemoglobin bind carbon dioxide, appear carbaminohemoglobin, which give the dark red color to erythrocytes. That's why if you will see the bleeding from any person, you can understand if the blood is bright red, it is arterial bleeding. If dark red, it is venous bleeding. Venous bleeding is not so dangerous like the arterial bleeding. Very pity, but our hemoglobin can bind carbon monoxide and form the carboxyhemoglobin. Carboxyhemoglobin, this word. The link between carboxyhemoglobin is stronger than the link of hemoglobin with oxygen. This carbon monoxide appear as in injectors as in the deficiency of the oxygen. And person who can breathe by this air with high concentration of carbon monoxide can die because of hypoxia of the inner organs. Carboxyhemoglobin forms the strong link with hemoglobin, and in lungs this link can't be broken, and oxygen can't bind the hemoglobin. Hemoglobin exists in different forms. Adult person has hemoglobin A, which constitutes 87% of total count. That is 97% A1, 2% A2, and some other A, more than A1, A2, and so on. And also hemoglobin F, only 1%. It is hemoglobin F, it is fetal hemoglobin of the fetus. Newborns has more hemoglobin F, but during the age, after some period of time, it's replaced by the hemoglobin A. People in the tropic countries can have hemoglobin S. Most of you are from the tropic countries, and you will meet this hemoglobin in your patients. It is abnormal form of hemoglobin, which appears as a result of mutation in the beta chain amino acid valine changed into glutamine. And it provides the so-called sickle cell anemia. This hemoglobin S changes the shape of erythrocyte and it becomes S-shaped. But this mutation is not fruitful for malaria plasmodium. And persons with sickle cell anemia don't suffer from malaria. But if this mutation is not dominant, and if person is heterozygote, has hemoglobin A in one allele chromosome, in second hemoglobin S, it is heterozygote, and this person has some features like subtle, not very tall, but he don't suffer from malaria and lives for a long time. But if person is monozygote for hemoglobin S, it is really sickle cell anemia. And person in this case don't suffer from malaria, but don't live more than 25 years. In medical, in biochemistry, you will study in details why. I want to underline that erythrocytes with hemoglobin S has special shape which looks like letter S. No, of course, not the full letter S, but something near. Next word, which can be in the list of the blood examination, which is printed constantly here, it is poikilocytosis. Poikilocytosis. You see this word, poikilocytosis. It is about the shape of erythrocytes. Usually in healthy person, 80% of erythrocytes are big concave disc, normocytes. But 20% may be in other forms, No more than 20%. Maybe echinocytes, erythrocytes with spines, stomatocytes, when appear the curvature in erythrocytes, which looks like mouth. Maybe erythrocytes, spherocytes, it is old erythrocytes. No, in tropic countries, maybe S hemoglobin. In heterozygotes, maybe up to 20%. It is it is for tropic countries very well. But if more than 20%, it means that person is sick. What diseases may be, I will not explain you. But you have to understand that if in list of the blood examination, laboratory underline the word poikilocytosis, it means that you have to think what happened and send your patient to the detailed blood examination. Later you will study what situations may be. Our blood for the blood transfusion is divided into groups. Today, there were in good clinics in many countries, blood is subdivided in more than one, according not only one type of classification of the blood groups. But in all the countries of the world, is spread the classification according the presence or absence of the glycoprotein glycophorin, this word glycophorin, on the cytosol of the erythrocytes. Glycophorin may be type A, may be type B, may be together A and B, or may be absent at all. And according to presence of glycophorin, we divides the blood into 4 groups. Group A, it is the second group which has glycophorin A. Group B has glycophorin B. Group 0 have no, it is the first group. And the fourth group has both A and B. To this glycophorin appear antibodies. And if you will transfuse the group, the erythrocytes with glycophorins, to the group who have the antibodies to glycophorin A, will be aggregation of erythrocytes, and it is mortal situation for patient. Now, the second class of formed elements of the blood, leukocytes, or white blood cells. Leukocytes or white blood cells. Leukocytes are really cells who has nucleus and has all panel of organelles. Leukocytes occupy the third line in the hemogram, and their account don't depends from the sex, is equal for both sexes. 4 to 9 times 10 power 9. All leukocytes are subdivided into 2 big groups or 2 classes. According to the presence or absence of the specific granules in the cytoplasm. All leukocytes has azurophilic or non-specific granules. Azurophilic or non-specific granules. These granules, it is lysosomes, function like lysosomes, and has the panel of hydrolytic enzymes inside. Specific granules present only in some special cells of leukocytes, which has the name granulocytes. In agranulocytes present only azurophilic granules, non-specific granules. In granulocytes present both non-specific granules, azurophilic, and specific granules. Specific granules, according its content, can have different color, can get the different color after Romanovsky-Giemse staining. And its classification into groups is based on the staining properties. If the granule stains in pink, it is eosinophils. If in blue, it is basophils. If cell has very small granules of both colors, red and blue, it is neutrophils. Has the neutrophilic look. All leukocytes can have very interesting ability. Leukocytes can pass across the wall of the blood vessels without damaging the wall of the blood vessel and go to the other tissues. And this process is called as diapedesis. Erythrocytes never leave the blood vessels in healthy person. Also, thrombocytes or platelets never leave the blood vessels in healthy person. But leukocytes can do this, and this process is called as diapedesis. But they can't return back to the blood vessels and stay, function and dies in other tissues of the organs. And only one group of leukocytes can return back. It is lymphocytes, granulocytes, lymphocytes. Lymphocytes can return back to the blood vessels and lymphatic vessels. And this process has name recirculation. Recirculation. The lifetime of leukocytes of various groups vary very much, from several hours up to many years. Leukocytes can live even all the lifespan of the person. So I told you that leukocytes are subdivided into two groups, granulocytes and agranulocytes. In the list of the blood examination, you can see the table of the leukocytic formula. All general blood examination count this leukocytic formula. It is very informative formula for doctors about the state of his or her patients. Usually, you have to know the account of each group of leukocytes in the leukocytic formula by heart, and all students on the exam can show us the knowledge about this account. No one student have to leave our department without knowledge about account of hemogram and leukocytic formula. How we can get these percents, account in percents, in the leukocytic formula? Usually laboratory or doctor, under the light microscope, on the smears, which are stained by Romanovsky-Giemse, find 100 leukocytes. Practically, you will look in the microscope, see the image, and count all leukocytes in this image. concrete image. And also you have to classify it according to groups. Then, without any system, you can change the image, push the microslide, and again count all leukocytes in this image and classify it according to groups. Finally, we have to count 100 leukocytes, and all of them have to be classified according to groups. If you don't know what type of leukocyte is it, you can't push it away. It means that something abnormal appear. And in this case, you have to understand, look in the special manual books or ask the more qualified or colleague with large experience than you, and try to understand what cell is it. That's why a count of each group of leukocytes or class of leukocytes according to 100 cells, it is percentage of each class of leukocyte and leukocytic formula. That's why if among 100 leukocytes you can find one eosinophil, it means that this eosinophil has 1% account in the leukocytic formula. If you will find 20 lymphocytes among 100 leukocytes, the percentage of leukocytes is 20, and so on. First group are granulocytes. In leukocytic formula, first of all, is written the granulocytes. Granulocytes, it is cell. All leukocytes are spheric, but granulocytes has segmented nucleus. Segmented nucleus. It is bright feature of granulocytes, like the specific granules in the cytoplasm. All leukocytes has all organelles in their cytoplasm. In leukocytic formula, neutrophils may be of three types. Young neutrophils. These young neutrophils, you can see here, constitute only up to 1% from total number of leukocytes. Young neutrophils has a horseshoe-shaped nucleus. It is really young cells which present mostly in the red bone marrow, but 1% of them can go to the peripheral blood. No more. If more, it is pathology. Second group, bent neutrophils. This is more mature cell, and these cells constitute 1 to 6% of total number of leukocytes. These cells has nucleus which looks like English letter S. Now you see the mature or lobulated or multilobulated neutrophils. This group of neutrophils constitute 47 to 72%. 47 to 72%. It is the largest group of leukocytes, of all leukocytes in our peripheral blood. These cells has 2 to 7 segments of the nucleus. It is very easy to recognize it under the microscope. You see 1, 2, 3, 4, 5 in this cell. This 1, 2, 3, 4, 5. Now these cells are more mature than this. It is near the band micro. Band has thick nucleus without this bridge of nucleoplasm, but with this curvature. That's why this cell is on the way to the formation in this neutrophil. But we recognize it as segmented, mature, multilobulated or simply lobulated neutrophil. You can see that in the cytoplasm of these cells present very small granules like dust. Some of them red, some of them blue, and that's why appear natural look of these cells. It is neutrophils. Transmission electron microgram of the same cell. You can see segments of the nucleus. You can see the small granules, very well developed Golgi apparatus, mitochondria you can see. You see here it is mitochondria and other organelles. Lysosomes also, non-specific granules. Some words about the content of the granules, specific granules. These cells are macrophages. They can leave the bloodstream, go to the loose connective tissue or other tissues, and move like amoeba. Then they come to the place of the invasion of something foreign. Something foreign we call as antigens. Foreign may come from outside or may be damaged own cells. Now they are foreign for us after trauma, for example. And if, for example, if appears some mutations, neutrophils come to these antigens and phagocyte it, if it is possible. Then the content of their specific granules, usually it is special enzymes, alkaline phosphatase, bactericidal cationic protein, and some other, and digest this antigen. That's why it is our first line of the defense from the invasion of the foreign particles into our body. It may be bacteria, pathogenic bacteria, viruses, fungi, pathogenic, and so on. Also, neutrophils, you will study in details their function in the Department of Biochemistry, Pathologic Physiology, because, due to the ability of these cells to initiate the inflammatory reaction and also stimulate the expression of some molecules of the immune response. Next granulocyte are eosinophils. Eosinophils, it is a granulocyte, and its account in leukocytic formula 1 to 5%. Their size 9 micrometers, and they has large, comparatively large specific granules. You see 0.5 to 1.5 nanometers of granules are large and red, bright red, eosinophilic. These cells has B-segmented nucleus, and now you see the erythrocyte. You see two segments of the nucleus and large red granules which occupy almost all the cytoplasm. It is transmission electron microgram. You see two segments of the nucleus, and here is specific granules. Pay attention that in these granules present special crystalloid. Only these cells in our body has granules with these lines, light, dark, light. Or for example, light, dark line, light, or light, or dark light, striated granules. These cells perform two very important functions. According to the content of the specific granules, they can kill the parasitic worms and protozoa which can infect us, and also they can increase the allergic reactions. So they help us if we have parasitic infections and allergic reactions. The content of their granules has antiparasitic factors and special enzymes like histaminase, which cleaves the histamine in the tissues and decrease the allergic reactions. Also, the cells can participate in the inflammatory reaction. A third class of granulocytes are basophils. Basophils constitute over 0.5 to 1% in the leukocytic formula. Basophils are large, comparatively large, 10 to 12 micrometers. They are also round-shaped, has all organelles and segmented nucleus. You see here, you see the markers of this cell. According to the CD classification, later we will talk about it. It is classification for immune cells. CD, clusters of differentiation, means. So their markers are CD40, CD mainly 40. Some other, but here you can see the basophil under the light microscope, after the Romanovsky-Giemse staining. Blue granules, you see large blue granules in the cytoplasm, and B-nucleated nucleus, two segments. Not B-nucleated, B-segmented nucleus, one and second segment, first and second. It is transmission electron microgram. Now you can see that in the section appear three new segments, 1, 2, 3, and large granules, electron-dense specific granules. The content of these granules are two antagonistic substances, heparin and histamine. Additionally, they can have eosinophilic hematotic factor, neutrophilic hematotic factor, peroxidase, and SRSA. These cells are the main cells which provide the allergic reactions. These cells produce histamine, the main substance of the allergic reaction. Histamine increases the coagulation of the blood and decrease the velocity of the extracellular matrix. That's why appear the edema, like edema of the quincke or local edema which erupted. But the second antagonistic factor is heparin. Heparin has another function. It decreases the coagulation of the blood and increase the velocity of the extracellular matrix. But heparin don't secrete very easy from the basophil. It can be secreted only together with the specific granules. Have to be degranulation of the basophil. But histamine can be produced in huge volume and can be secreted without any problems from the cell. That's why mankind today suffer from the allergic reactions. And I want to repeat once more that the main cell who can decrease the allergic reaction, who can deactivate and cleaves histamine, it is eosinophils. But these cells are not numerous and can't help us very quickly. And the second group of leukocytes are agranulocytes. Agranulocytes, the first has unsegmented nuclei. All of them has nuclei, but nucleus are not segmented. First group, it is lymphocytes. Lymphocytes constitute 17 to 37% in the leukocytic formula. Lymphocytes may be small, 6 to 8 micrometers, may be medium size, 8 to 18 micrometers, and large, more than 18 micrometers. Now you see lymphocyte. It is slightly blue cell, it is erythrocyte. You can see that leukocytes has blue cytoplasm, basophilic cytoplasm, and very large spheric nucleus. This is nucleus. I think that it is medium-sized erythrocyte and it is small erythrocyte. This is transmission electron microgram. You can see spheric cell with the large spheric nucleus, non-specific granules in the cytoplasm, and all panel of organelles, mitochondria, rough endoplasmic reticulum, Golgi apparatus, and so on. Very interesting. What type of leukocyte is the more mature? Small leukocytes are mature. Large lymphocyte is young cell. Now you see the large lymphocyte. You see that it is larger than erythrocyte, maybe in 2 times or more. This cell really large, is large nucleus and thick ring of cytoplasm around, blue of course. This is young cell who is the first step after lymphoblasts, who rest in the red bone marrow. Leukocytes may be of two classes, B lymphocytes and T lymphocytes. B lymphocytes we call as effector cells. These cells can transformate into the plasma cells, but they have to be stimulated by T lymphocytes. Stimulated B lymphocytes differentiates into the plasma cell, which go to the extracellular matrix outside the blood vessels, then to the tissues around the vessels, and transformates into the plasma cell. Now you see the plasma cell. Plasma cell can produce so-called antibodies or immunoglobulins. Next group are T lymphocytes. T lymphocytes, it is not effective cells. These cells can provide the immune response. So these cells are subdivided into several types. First type, cytotoxic killer cells. These cells can produce special substances like crimson and perforin and kill the foreign cells. Foreign cells may be own malignant cells, may be own cells infected by the virus, or may be transplanted cells or cells of transplanted organ. These cells are very strong and in all cases kill the transplanted organs. But against the malignant cells, they are not so active because malignant cells can mimic for the own cells and killer cells don't see them. You will study it later when you will study the pathology physiology and pathology histology. The second class of T lymphocytes are helper T cells, who enhance the activity of the B cells and other T cells. Suppressor T cells can activate the activity of the B cells and their transformation into plasma cells, and also they can activate some T cells. Also, nature killer cells. These cells are programmed during their development to kill certain viral infected cells and some types of tumor cells. If cytotoxic cells can kill everything, nature killer cells programmed only for concrete, for certain viral infected cells, which they met earlier, or some tumor cells. Under the light or electron microscope, we can't separate different types of T lymphocells, recognize them, or we can't principally recognize is it B cell or T cell. Special classification which uses the immunohistochemical reaction and based on the reaction of antibody and antigen can help us. Now we know that different classes of B lymphocytes, T lymphocytes, has protein molecules, specific protein molecules on the cytosol or in the cytoplasm, which can bind its own antibody. And according to the presence of these protein molecules, appear the classification CD, clusters of differentiation classification. And in this slide, you can see that, for example, nature killer cells has CD16, CD56, and CD94 protein molecules. And it is markers of this class of T lymphocytes. Usually, B lymphocytes has CD90. All T lymphocytes has CD3 marker, and so on. The last class of monocytes are monocytes. They constitute only 3 to 11% in the peripheral blood. It is very large cell, over 12 to 15 micrometers in diameter, and has horseshoe-shaped nucleus. These cells, here you can see it, has non-specific granules. You see large soybean or horseshoe-shaped nucleus, comparatively oxyphilic cytoplasm. Here it is the transmission electron microgram. You see large nucleus of very specific shape, large cell which has all panel of organelles. Monocytes lives in the peripheral blood only 6 to 8 hours. Then they leave the bloodstream and go to the tissues which are around the blood vessels, connective tissue, muscle tissue, or nerve tissue, and transformates into the macrophages. You see macrophages. Macrophages, I'm sure you know, can perform phagocytosis. It means that macrophages are cells who can find something foreign and engulf it, phagocyte. That's why in immunology we call macrophages as antigen-presenting cells. Antigen-presenting cells. Later we will study immunology and again talk about macrophages. These cells can digest antigen in their lysosomes, non-specific granules, and divide it into epitopes. Macrophages form so-called mononuclear phagocyte system. Mononuclear phagocyte system consists of monocyte-derived phagocytic cells throughout the body. During the development of histology, in almost all organs was found cells who can phagocyte something. And historically, they get name according to the authors who opened them, who described them. Now, for example, in liver, it is Kupffer cell. In skin, it is Langengar's cell. In pleura, it is pleural macrophage. In, for example, in lungs, it is dusty cells. And in nerve tissue, it is microglial cells. All these cells, macrophages, originate from the monocyte of the blood. Next. So monocyte, it is the last group of leukocytes in the leukocytic form. And the last line in the hemogram take the platelets or thrombocytes. You can see platelets or thrombocytes. It is very small formed element which are part of cytoplasm of very huge multinucleated cell megakaryocyte. These cells present in the red bone marrow. Part of cytoplasm of these cells demarcated by the demarcation canals from the large cell and go to the periphery. That's why platelet has no nucleus, most of organelles, and has only granules. Granules of three types: alpha, delta, and lambda. Now you see the large cell, megakaryocyte, one of its nucleus, cytoplasm. You can see the demarcation line and platelets who separates from this cell. In the peripheral blood, these platelets are very small and consist of hyalomere, this is cytoplasm, hyalomere, and granules, granulomere, hyalomere and granulomere. Granules, content of the granules are proteins of the blood coagulation. Now you see the platelet, you can see granules, granulomere and hyalomere. These cells, these platelets constitute 270 to 320 times 10 power 9 in 1 liter in hemogram. That's why platelets function is blood coagulation. After the injury of the tissue, after trauma, appear bleeding, and platelets are cells, it is not really cells, cells of the blood, who quickly go to this region and coagulate. First of all, appear the adhesion of these platelets to one another, then aggregation, then it's interact with some tissue factors which appear, plasma bond factor, and also platelet-derived factors which locates in the granules, and appear the clotting of the blood and blood coagulation and bleeding stops. The main protein of the blood coagulation in the granules is prothrombin. Prothrombin. Maybe it is your future, but you will know that 25 factors can come together for the blood coagulation. 25 factors, so many. And some of them present in the granules of the platelets. And a few words about reticular tissue. Our lecture go to the end. Reticular tissue is a specialized type of the connective tissue which provide the microenvironment for the blood-formed elements in the hemopoietic organs. Reticular tissue, it is really connective tissue, but very special, which we can find only in the hemopoietic organ. It forms reticulum. Why reticular tissue? In this tissue, cells, so-called fibroblast-like cells or reticular cells, has processes, you see processes, and fibers, reticular fibers. Now we know that it is collagen type 3. That's why together reticular cells contact with one another by the processes and fibers, you see fibers, and together they form the reticulum or mesh. And in this mesh, in these free spaces, develops and live the blood-formed elements. Here appear the new clones of leukocytes, of platelets, omega karyocytes for platelets, and erythrocytes. So, doctors, thanks for your attention. Our time come to the end. I tell you all the material about the topic blood and lymph. So the lecture is over. You may be free. Goodbye. Алло, все, у меня закончилось. Я не знаю, как его выключить. Спасибо большое. Хорошо. Спасибо. Не знаю, как выключить. Мне же, наверное, слышать.
Попрощались.
Скажите, говорят, какие-то они должны лайки ставить, что-то такое, так что такое, так где? Это здесь не может быть? Игорь Анатольевич говорит, что вроде как-то учитывать будут, нет?
Так, мы завершаем, да, трансляцию?
Да, все, слышку я заберу. Так.